This is question 50 of the electric fields and the capacitors homework booklet. So in question 50, what we have is we have a 2 microfarad capacitor which is charged up through a resistor from a battery which has an EMF of 4.5 volts. We're asked to sketch a graph on the axis that we're given to show how the charge stored varies with potential difference across the capacitor whilst it's charging. And we're asked particularly to mark appropriate values on the axes of the graph. So basically we've got to choose some values to show some characteristic values for this particular capacitor. So the first thing to know is that the relationship between the charge and the potential difference is a linear one, because if we look at this particular equation over here, charge is directly proportional to the potential difference because capacitance is a constant. So therefore we know that this thing must be a straight line that goes through the origin. And even if we just draw a straight line that goes from the origin, that gets us one of the 2 marks. The second mark is for putting appropriate values on. So we know that in the end, the EMF, the potential difference across the capacitor will be equal to the EMF of the battery. So therefore, the potential difference across the capacitor will be 4.5 volts. We simply need to work out what the corresponding value of the charge is. Now, again, if we go back to this equation over here, then we simply use the values we were given in the question. So the capacitance is 2 times 10 to the minus 6 farads. The potential difference is 4.5 volts, which gives us 9 times 10 to the minus 6 coulombs. So if we simply mark that on, and then we just basically draw some lines just to show that those values are characteristic for this particular capacitor. Put both of those values on the axes, gets you the second mark. We're then asked to show that the energy stored by a charged capacitor is given by this equation over here, which is in your data booklet. We simply have to show it. So basically what we start off with is this is our equation for potential difference. So potential difference is defined as the work done per coulomb. If we rearrange this, we basically get work done is charge multiplied by potential difference. So that's what this says. Now, from the graph, the work done is simply given by the area underneath here, like that. So if the potential difference was a constant, this is the equation that we would simply have for our capacitor. However, for a capacitor, it's not. Potential difference as it's charging up changes. So basically, we use the graph, and so the work done is the area underneath the graph. So because it's a triangle, we end up with half V times Q. So therefore, the area is equal to the total work done, and so the area is half VQ, and so therefore we've basically shown that this is the energy stored by a capacitor is given by this thing here. And if we do that, then basically what we've said is if we write this equation down and explain what it is, that's 1 mark, and then secondly saying that the area gives us the total energy, which leads to this equation over here, gives you the second mark. So in the second part of this particular question, we're asked to simply calculate the energy stored by the capacitor, which is given in part A, when the potential difference is 1.5 volts. So the energy is equal to a half CV squared. That's simply an equation that we've seen before, and you can also get from your data sheet. So the capacitance we were given before, which is quite simply 2 times 10 to the minus 6 farads, it was given up in the question up here, right at the start of the question. And the potential difference is 1.5 volts. So we simply substitute those numbers into this equation, and that gives us 2.3 times 10 to the minus 6 joules. Now the whole part of part B was worth 5 marks. So basically what we've got to break the marks down, this explanation here is worth 1 mark, showing that basically and then explaining that the area underneath the curve basically is your second mark, and that leads to this thing, which is the third mark. For the fourth mark, you simply have this equation here with the right numbers substituted in it is your fourth mark, and then your fifth mark is getting the right answer. So that was question 50 of the electric fields and the capacitors homework booklet.